So now we're going to be looking at the fundamental theorem of calculus. Okay, so far our we haven't had any limits of integration. Okay, and so now that we have these little numbers on our integral sign, that's what they're called, limits of integration. We're looking at the fundamental theorem of calculus, and it's talking about area under the curve. So I gave you some notes to read over, and let's look at how to work the problems. Super easy. Alright, so I've got the integral from 0 to 2 of 2x dx. Okay, so again, this 0 and this 2, those are called your limits of integration. And so what you're going to do is integrate your function how you have been doing it, but you won't have a plus c anymore. What you're doing is finding the area under the curve from x equals 0 to x equals 2. And so you're going to plug those numbers in at the end. Alright, so the first thing you want to do is integrate it. So you've got 2x, and you know it's to the first power. So if you add 1 to it, you divide by the new power, you end up getting, this is x squared. Okay, but now we're not going to write plus c anymore if those little limits of integration are there. What you're going to do is we usually draw a line and we say, I want to integrate this from 0 to 2. So I always tell people to draw 2 circles, and you're going to do the math out. In the top one, in the first one, you plug in the top number, so you plug in 2 here, 2 squared, and then here you plug in the bottom, which would be 0 squared. So you end up with 4 minus 0. So your answer is 4. No longer do we have the function plus c. We have a number answer that represents the area. Okay, so let's keep going. All right, and we'll scoot this up. Integral from 0 to 1 of 4x plus 1 dx. All right, so we got to integrate a 4x, and we got to integrate a 1. So here I already have a 1, add 1 to it, divide by the new power, and I integrate a constant by just sticking on an x. So I end up with 2x squared plus x, and I'm going to go from 0 to 1. So again, draw your 2 circles. So in the first circle, I'm going to plug in 1. 2 times 1 squared plus 1. And here, I'm going to plug in 0 for x. So I end up with, alright, 1 squared is 1 times 2 is 2, 2 plus 1, so in this circle I get 3, but here I just end up with 0, so my area is 3. Okay? Alright, now look at this one. Doesn't look like the one I just had because I have this squared power. Okay, so you know when you see a parenthesis to a power, okay, I have 2 options. I could square it out and then integrate it, but we know u substitution. So let u be the inside. So du is 4 dx. So this becomes integral from 0 to 1 of u squared. And then I need 4 dx, and I don't have it, so if I'm multiplying by 4, I cancel it with the 1/4. Okay, and then there's my du. So I have 1/4 u squared that I want to integrate. So if I add 1 to it, my new power is a third. Is 3, and so I'm going to divide by 3 or multiply by a third. So I end up with 1/12 u cubed, or 1/12 4x plus 1 cubed. And again, I want to go from 0 to 1. Alright, so I've got to move. I need plenty of room to do this math. Alright, so in the first circle, I'm going to plug in 1. Okay, and in the next one, I'm going to plug in 0. Don't say that the whole thing zeroes out, because it won't. Alright, just be really careful, and if you know you're bad with computation, use calculator. So that's a 1/12. Alright, 4 times 1 is 4 plus 1 is 5. 5 cubed. And I'm about to use my calculator in just a second. 4 times 0 is 0. 0 plus 1 is 1. So that's not bad. This is just going to be 1 cubed is 1 times a 12th is a 12th. Okay, but this one's going to end up being 125 over 12. So I end up with 124 over 12. And if I punch that in my calculator, I get it doesn't go evenly, so if I reduce my fraction, I end up with 31 over 3. There you go. All right, so let's look at this one. Okay, integral of 0 to 3 of e to the 2x dx. So our last lesson was talking about these. All right, let u be the exponent. So du would be 2 dx. So let's do our replacing. So this becomes e to the u. All right, I need 2 dx and I don't have it, so if I'm multiplying by 2, I cancel it with a half. And there's that, so I end up with 1/2 e to the u, or 1/2 e to the 2x, and I want to go from 0 to 3. All right, so I have 1/2 e to the 2 times 3 minus 1/2 e to the 2 times 0. So that's 1/2 e to the 6th minus, all right, be careful here, it's 1/2 times e to the 0. Well, anything that raises 0 power is 1. So this part right here equals 1. So it's just 1/2 times 1, so just a half. So I would probably give the answer as 1/2 e to the 6 minus a half. Or if you want to factor out that 1/2, sometimes you see this part. And if it wasn't that, then it wants you to punch it into your calculator. Alright, let's do this one. Integral of 1 to 4. Alright, first thing I'm going to do is rewrite that as x to the 1/2 dx. Alright, let's integrate that. So back to fractions. If I add 1 to it, I'm going to add 2 over 2. Okay, so my new power is 3 over 2, and dividing by 3 over 2 is the same as multiplying by 2 over 3, right? Okay, so what happens with those 3's is they cancel, so I end up with negative 2 x to the 3/2, and I want to go from 1 to 4. So negative 2 times 4 to the 3/2, and a negative 2 times 1 to the 3/2. You want to be careful and watch these signs, okay? Alright, so that's going to be a negative 2 times, alright, 4 to the 3/2 would be square root of 4 is 2, 2 cubed is 8. I'm going to go ahead and write that as a plus, and then that's just 2 times 1 to any power is just 1. So negative 16 plus 2, so my answer is negative 14. And then let's do our last one. Now this one, I gave you the picture. You know you're going to end up integrating 1 minus x to the 4th, okay, because that's the curve it gives you. Right? But what you don't know are the limits of integration. Okay, you take them off the x-axis. So that's a negative 1 to a positive 1, because what I want to do is I'm looking at the area of this curve, under this curve. So you always read it from left to right. That becomes your bottom, and that becomes your top. So I'm going to go from negative 1 to 1. Alright, so if I integrated this, integrating a 1 is just an x. And here, if I add 1 to it and divide by it, I get minus 1/5 x to the 5th. And I want to go from negative 1 to 1. So that's 1 minus 1/5 times 1. And a negative 1 minus 1/5 times a negative 1 to the 5th. Oop, I forgot my 5th here. Alright, so that becomes 1 minus 1 to the 5th power is just 1 times negative 1/5. That's that. Alright, this is a negative 1, and negative 1 to the 5th would be negative 1 times a negative 1/5 would be positive 1/5. So that is 4/5 minus, alright, that's going to be a negative 4/5. So I end up with 4/5, those switch to a positive, plus 4/5, and I get 8/5. Okay. Now, again, you get to use a calculator, use it. Don't feel like you have to do all this by hand. But go practice some homework.